Hi, welcome to the shop. This time I wanted to try something new. I want to do a monthly video, kinda shop video, kinda like Tom Lipton or Adam Booth do them. I don't have enough content to do a weekly video, so I will try to do it on a monthly base. I will talk about new acquisitions for the shop, interesting little jobs, or just project updates. And to begin with, I have this boring head. It's a German-made UPA1. It's not only a boring head, you can move the slide with this ring and it traverses to do normal boring, but you can also engage a fine feed, and while it's rotating you hold this ring and it feeds out, so you can surface a like a flange, or you can machine internal snap ring grooves with it. Why I show this? Because I have to do a lot of small hole boring, and this boring head takes only 8mm tooling. So I had to make these little bushings. They are stepped, they have an 8mm shank, and they are drilled and reamed to 3, 4, 5 and 6mm to take smaller boring tools. I have one of those boring tools here. This is ground of an old carbide shank, 3mm shank, and it's almost ground like a single lip cutter. You take down to half the diameter and grind relief on the front and on the side. But as it's obvious, it's too small to fit. The bushings are slit. They are made from free cutting mild steel and they are case hardened. So the boring tool goes in, the cutter goes in, and you clamp. You try not to clamp on the slit. You just need to rotate it a little bit, clamp it, and you can do pretty small boring operations with this big boring head. So, and now I will show you how I made these bushings and also the case hardening process. Okay, we have everything set up. Now we're going to take one of the bushings. I will do them individually on a piece of baling wire, so I don't burn my fingers. Then get my glasses on. This is a pretty nasty process. You need to wear safety glasses, as pieces of the case hardening compound will fly around and you don't want to get those fragments in your eyes. So you start to heat your part until you get to glow pretty even. And then you drop it in the case hardening compound. The compound melts on the part and then you let it soak with the torch again. When you drop it in the water, it will be pretty violent. The case hardening compound will splash around, so be aware of that. Okay, and there we go. And the part when it comes just out, a bit scaled, but not too bad. And if I get an old file, it's, as you can hear, it's file hard. Okay, I decided to get rid of the scale. So I put the pieces in a cup with hot water and some citric acid. Okay, now it has soaked for about, it has almost removed. I will only wash the acid off and oil them. Okay, I want to show you this little guy. I was asked about it and it doesn't seem to be too common. This is a kind of a V-block, and its purpose once was for machining electrodes in for RAM EDM machines or sync EDM machines. The V-block consists of two parts. The main block is all ground and hardened tool steel. It has a square footprint, a round boss and a cutout. The cutout is exactly parallel and 90 degrees to the footprint, and also perpendicular to the bottom surface, or to the surface it sits on. The second part is this ring with the 3 thumb screws. They have brass tips so you don't mar the pieces you're clamping. The ring is a pretty tight fit. It goes over this boss, and now you can use it to hold small parts, mostly rectangular or square parts which are pretty long and thin in an upright fashion. Say if you have, this is parallel, say if you want to machine on the front of this piece and you want to clamp it standing on the machine table. You could use this. You put it in, it's clamped with the 2 screws. And what we have done, we pushed the part into the corner against this and this surface. It's clamped and it's rectangular to the perpendicular to the table and also square to the footprint of this V-block. The great thing about this thing is the repeatability. You have 10 pieces, all the same outer dimensions. You machine the first one, you open the screws, take it out, put the next in and clamp it again, and all of the parts will locate exactly at the same place in this V-block. It also works for round parts. Then the screw diagonal to the clamping surfaces is used. Say if you want to machine at the end of this punch, you put it in, get your ring up. This ring is free movable. If you have to do a lot, you can put the parallel under it so it doesn't always fall down. And you put your part, in this case this punch, in and clamp it. So it's also registered against these 2 surfaces and clamped with that screw. If you have a lot of parts with the same length, you can let them rest against the machine table you have clamped this to. If you want the pieces to stay up off the table, you can use a gauge block that gets put under. Take the ring off so you can see. You can put a gauge block under, and now you can rest your workpiece on that and put your ring over and clamp it again. So if you have a lot part with the same length, you don't have to touch off all of them individually. Okay, we're back at the milling machine. Another task I want to talk about is aligning the vise with the machine. A lot of people have trouble doing this, and you see people running an indicator across 50 times, tapping the vise in different directions with no clue what to do. And I wanted to show you how I do this. I use these stepped bars which engage the slots on the side of the vise and which are held down by 2 T-slots. I will leave one off because I want to rough align it with my square. I put the T-slots in the machine table are ground within the direction of the table, so I can use my square to do a rough alignment of the vise. Just push it against it, remove it, and set the bar against the vise. Now I tighten all screws very lightly, just with the short end of the Allen wrench, just snug it up a little bit. And one I tighten down a bit more. Because I do this, I get a swivel point around which the device turns when I tap it sideways. So this is my fixed point, and this side of the fixed jaw we're going to rotate our dial test indicator. I set it up against the vertical way of the machine, get it into contact with the fixed jaw of the vise. So I'll bring the camera around so you can see what happens on the dial test indicator. Okay, what I'm going to do is I will run the table over and see what the needle does while contacting the vise jaw. And it drops. So the needle went this direction, so I need to tap this side of the vise, so the fixed jaw goes this direction. Okay, now I got a rough alignment. I put my needle back to 0. Okay, now you can see the needle better. So let's run it over again. Now you see it rose just about a little under 1/100th of a millimeter. So I need to tap this side, the right side of the vise just a little bit. This might be too much. Now I'm going back and the needle stays in place. Now I tighten these screws down, all 4 of them. Double check it, and it's almost. The needle doesn't move almost. So if you get the hang of it, you can trim the vise within 1 or 2 minutes.